October the 1st, 1963. Here in Washington, the day begins quiet. For some, it starts early in a federal agency that today marks its first 5 full years of accomplishment. This is NASA, the National Aeronautics and Space Administration. As the day begins at NASA headquarters in Washington, and dawn comes to the Capitol, the rising sun outlines the gantries at Cape Canaveral. NASA's Launch Operations Center begins a new day. At other NASA stations, far to the west, it is still night. Signals from satellites in space are being monitored for later study. NASA's 5th anniversary comes quietly. Yet these 5 years have been memorable, exciting. Most Americans can remember the rockets climbing into the sky with their cargoes of instruments, or of men. And a nation's pride in its new achievements in space, and the tribute offered to that new breed of man, the astronaut. They remember anxious moments, too, as search planes hunted a capsule returned from space. What America achieved in those first 5 years of the civilian space program was done openly. A nation dedicated to freedom of inquiry could not do otherwise.
Bear with me, I will get you a number and deliver that tomorrow.
These were the years Americans learned new words: liftoff, SYNCOM, Tyros, fly-by-wire. If our successes were spectacular, so were the failures. Failure itself was studied, closely, patiently. Progress into space must come step by step. To NASA facilities like Goddard Space Flight Center came research scientists, Americans and visitors from other nations. They saw programs that investigate fundamental physical phenomena, an indication of NASA's increasing role in the advancement of basic knowledge. From these centers across the nation, NASA's space program is guided and directed. In 5 years, the world has been dotted with a network of tracking stations that monitor space probes, unmanned satellites, and our astronauts in orbit. The status and position of every space vehicle and a mass of other scientific data are transmitted from the tracking stations to control centers. All of these facilities are staffed by engineers, scientists, and technicians already veterans of the space age. From these ingredients of knowledge and skill, of facilities and equipment, of a guiding organization, America's achievements in space have been created. They began more than 5 years ago, when America's first satellite, Explorer 1, rose from its launching pad. It carried into orbit the means for performing an historic scientific experiment, one that first revealed the Earth's belt of radiation. It has been followed by well over 100 spacecraft launched by the United States. Satellites and space probes on scientific missions are the vehicles for experiments by the Earth-bound investigator. Here is the space probe Mariner 2, shortly before its 1962 launching on an historic flight to Venus. For 109 days, Mariner transmitted back to Earth continuous data on conditions in space. Then, at a distance of 36 million miles, it sent back important data on the planet Venus, a record-breaking achievement. One of the scientific satellites, the orbiting Solar Observatory, has provided precise information about the sun and the effect of its radiations on the upper atmosphere. The satellites and the space probes have given man new tools to study the mysteries of the universe, where before he could only wonder and speculate. Other satellites, some of them closer to Earth, are solving practical problems in the field of communications. The first to go up was Echo, a giant balloon. It provided a surface in space from which radio signals were reflected. Telstar, privately financed and NASA launched, and Relay, NASA's own satellite, heralded a new era in global communication. Their first transmissions dramatized the future, a permanent system of communication satellites. SYNCOM, a satellite that maintains an almost fixed position over the Earth, represents another approach. Here, messages are received from SYNCOM, hanging 22,000 miles overhead. The weather satellite Tyros, mounting 2 cameras and a television tape system, returns photographs to Earth on command. Tyros photographs of cloud cover are valuable aids in discovering the growth of storms and in plotting basic weather patterns. But no satellite, however complex, has the power of observation and understanding possessed by man himself. There is no substitute for manned flight into space. In the famous X-15, NASA continued a development in rocket-powered aircraft extending back over 15 years. Over 100 times, the X-15 has climbed above our atmosphere. It was the first craft to demonstrate that man can fly into space, control his flight during re-entry, and select his landing point within 1,000 feet. Project Mercury, the manned orbital spaceflight program, selected 7 pilots after intensive screening of many candidates. Skin diving was one part of an elaborate program to train them for flight into space and a safe return. They studied the navigation, the engineering, the physical problems of space flight. They learned the sheer ability of the human body to withstand high temperatures. And experienced other punishing stresses of a journey out of this world. Even zero gravity, that peculiar property of spaceflight, was sampled in an aircraft flying a controlled arc. Finally, the long program of training, development, and testing was complete. Opening the major phase of Project Mercury, there were suborbital flights by astronauts Shepard and Grissom. Then, in February 1962, John Glenn rode this Atlas rocket into space for a 3-orbit flight around the Earth. Project Mercury moved into high gear. Within 3 months, another successful flight was completed by astronaut Scott Carpenter. Then a 6-orbit flight by astronaut Walter Schirra. In May 1963, when Gordon Cooper returned to the Earth after a flight of 22 orbits, American spaceflight reached a state of high precision. Project Mercury was completed, but it was only a first step toward the goal that now lay ahead. A voyage to the moon and return by 1970. It would be an historic achievement with immense practical consequences. But the technical problems dwarf those solved in Project Mercury, demanding absolute precision in orbiting and new techniques for rendezvous, docking, and landing. First comes Project Gemini. Unlike Mercury, 2 men will fly Gemini in orbit for up to 2 weeks, practicing space rendezvous and docking. Gemini capsules are now being built and tested. Apollo, the 3-man craft that will actually go to the moon, is also undergoing a long period of test. This is Saturn, first of the family of giant boosters that will lift man to the moon and beyond. Product of more than 5 years of intensive research and development, Saturn undergoes a major flight test. On this day, we moved at least 1 step closer to the moon. Visiting Cape Canaveral are the new astronauts, the men who will join the original 7 and ride the Gemini and Apollo spacecraft. They are the new pioneers of space, but their path has already been charted by those who have gone before. For these first 5 years have been a sustained effort, an effort that has broken through the first barriers to man's exploration of space. Because of this first giant step, the cosmos opens itself to man's investigation. What will he discover on these journeys? Already he has seen the Earth as never before in his history and viewed parts of the universe with new clarity. Perhaps now he'll discover clues to the origin of life itself, and through them a glimpse of its purpose and his own. These 5 years have seen the first bold steps forward. Today, experienced, tested, capable, we look with confidence toward the future and our path to the stars.